Hello everyone, welcome to the world of data structures. Our today's topic is B tree deletion or deletion in B tree. Hi, this is your instructor Janice Shah. So let's begin with the today's outline. Students, the outlines are, first we'll talk about that rules for deletion in B tree. Then we'll see the demo example that how to calculate the minimum and maximum values or subtrees for order in B tree, and then we'll see deletion in B tree with example. So here are some rules for the B tree deletion. Students, I suggest please kindly bring your notebooks and pen with you because these rules are very much important for the further deletion process in B tree. Okay. So while deletion, students, there are different cases to be considered over there. So first is delete a value from leaf node. So first the case number 1 is a situation where you want to delete a node or you want to delete a value from the leaf node. So here first you need to locate the leaf node, okay, and then if the first part of case 1, that is if the leaf node contains more than minimum number of values. Okay, students, what do we mean by the minimum number of values? Have you ever seen the table in my previous lecture where I have shown you that the root node must contains minimum subtrees? So these are the basic rules, okay, that the minimum values must be like this or minimum subtrees are must be like this. Fine. So if your leaf node contains the minimum number of values, then what to do? Then you just need to detect the delete that value from the leaf node. Okay. Now about the else part. Suppose our node does not contain, or our leaf node does not contain the minimum number of key values. Okay. Such, taking an example that our leaf node may be leaf node order of 5. Okay, must contain at least 2 values. Okay, 3 subtrees, that means 2 values. Okay. So what does it mean? That leaf node must contains 2 values. But in a situation, suppose leaf node does not contain any 2 values for the deletion operation, then what to do? So here if a leaf node does not contain minimum number of values, students, then you need to take the value from the left sibling or right sibling of that leaf node. Okay. So here, so points that how can we select the left sibling and right sibling? That if the left sibling has more than the minimum number of key values. Students, if your left sibling has more than number of minimum key values, then put the largest value, push in the parent node. What you need to do is you just need to take the largest value from the left sibling, and push into the parent node, okay, and take the intervening value. Students, what does it mean by the intervening value? We will see in the example. Okay, so take the intervening value from the parent node to the leaf node. Okay, now what happens to the next scenario? Suppose students, if your right sibling has more than minimum number of key values, then what to do? Suppose your right sibling has more than number of key values, then take the smallest value from the right siblings. You need to take the smallest value, okay, and then put it into the parent node. Take the smallest value from the right sibling, put into the parent node, take intervening value and put down into the leaf node. Okay, so such like this you can do the deletion operation. Okay, now the next scenario is, students, next we have another rules, third point. In the first case, now we are going to see the third point, that suppose your left node and right sibling, does not contain, okay, minimum number of elements. That means firstly you are depend on the values of left sibling or right sibling, but now the scenario is that both left and right does not have minimum number of key elements. Then what to do? Students, in such type of scenarios, you just need to merge or combine with your left sibling or right sibling and your intervening node. So what you are going to do is, you are just going to combine your node with intervening node and intervening node from the parent node and the left sibling or right sibling. Okay. Now, the next we have case number 2. Delete a value from internal node. Suppose in such cases, if I want to delete a value from the internal node, then what should I do? So in such type of scenarios, promote your successor value or predecessor value of the key to be deleted occupy the position of deleted key. So if I have 100, 88 and 70 with me, okay, 100, 88 and 70 with me, then 70 becomes predecessor of 88 and 100 becomes successor of 88. Okay, so what you need to do it, if I want to delete 88, then I need to choose either 70 or 100. Fine. So successor and predecessor take the values for the internal nodes. Now next we have, okay, see the demo example of B tree. Suppose here we have our B tree, okay, 66, 35, 45, then 80 and 100. On the next we have 20, 30, 40, 50, then 55, 70, 75, 90, 110 and 120. This is our B tree. Students, just imagine that this B tree contains of order 4. So here order is 4, so students, you can insert more than maximum 3 values in a node. 4 pointers, 4 child can be possible, but values in an element in the node are 3 only. Okay, so there are only maximum 3 elements are there in a node and 4 pointers or 4 child can be there. Okay, but what are the number of values? So in leaf node the minimum values must be 1 and maximum must be 3. Okay, for the root node students, the subtrees are, the minimum subtrees at the root node are 2, the maximum 4, and the internal the minimum 2 and maximum 4. Okay, now next we have, so here is the example of B tree deletion. So this is our B tree. Okay, so students, right now we already have a B tree with us. So the values are, at the root node we have 108, only one element is there. Okay, on the left side of the 108 students we have 63 and 81. Okay, right side we have 117 and 201. Okay, the other elements at the leaf node are 36, 45, 72, 79, 90, 93, 101, then 111, 114, then 157, 180, 243, 256, 333 and 450. Fine. Now let's see first the order of this B tree. So students, here we have the given order is 5. Students, given order is 5, so maximum values you can insert over here is 4. Okay. So now, according to the formulas of subtrees and the minimum values, I am just giving a short overview over here that where we need to apply that rules. Okay. The rules should not be violated by the leaf nodes or any type of node during the deletion. Okay. So here we are going to consider the minimum values. The minimum values at leaf node must be 2. That means your leaf node should contain at least 2 values. Remember this. For the order 5, your leaf node should contain minimum values 2. Now, what about the root node and internal nodes? See, the leaf node contains minimum values 2, the root node contains the minimum value 1, and the internal node contains minimum values 2. Okay, check out this, check out over here. Over there we have the subtrees, so just make a -1 from subtrees and you will get your minimum number of values, where we have students at root node the minimum values 1, internal node and leaf node we must have minimum values 2. Okay, so in any cases during deletion, if your node violating these rules, then you have to apply that cases. Okay, so let's begin with the deletion operation very first. So here we have first example of B tree deletion. Order is 5, so you can store maximum 4 values, and I have already written over there the minimum number of values, because in deletion I need to focus on minimum values. In insertion we are focusing on maximum values. Fine. So minimum values in each node is written over there. root node 1, internal and leaf node both contains 2 minimum values. Now, this is my figure, same as the previous. Okay, now let's begin. So, very first, if I want to delete a node 93, students, if I want to delete a node 93, so I'm just highlighting it. So here it is my node 93. Okay, now tell me, 93 is a leaf node? Yes, 93 is a leaf node. Okay, so same as insertion here, each and every operation starts from the leaf node. So students, make sure that 93, that node, the whole node contains how many values? 3 values. How many values? 3 values. Fine. So a leaf node must contains minimum how many? 2 values. If your leaf node contains minimum 2 values, then it's okay. But here your leaf node contains 3 values. So after removing 93, okay, if I delete a 93, is there any violation of B-tree deletion rules? No. Okay, because all going fine, I can delete 93 directly. So this is case number 1, where you are going to delete a leaf node that contains more than number of minimum key values. Fine. So what you can do over here, I can directly delete 93 from this figure. So here it is. Now see, 193 is gone. So what I need to do, I just need to combine 90 and 101 together. Okay. So that is a first deletion of 93. So 93 successfully deleted. Now the next value we want to delete, that is 201. Okay, students, if I want to delete a 201, that means it is situated at the internal node. See, I'm just highlighting 201 over here. So my 201 node is there. 201 node is there. Okay, that is internal node. So this becomes my case number 2. Case number 2. Okay. So tell me, if I am going to delete 201 from that internal node, then what happens? What happens? It is just violating the B-tree rules, because internal node must contain 2 values, minimum 2 values. So if I am just removing 201 from that node, then 117 becomes alone. 117 becomes alone. So it is not right for that according to the B-tree rules. So what I need to do is just check out a case number 2, where you need to select either predecessor or successor. Okay. Okay, so from which node I need to select the predecessor? So you can select the predecessor or successor from its child nodes. Fine. So here, see, I have 2 choices. Here I have 2 choices. Choice number 1, I can select the successor node, that is 243. 243, check out the sequence. Okay, so after 201 it comes 243. So I can select 243 and put over there, or I can select 180 and put over there. Now it's your turn to tell me that what I need to choose, 180 or 243. Okay, so just wait for a few seconds, students. Whether I need to choose 180 or 243? Obviously 243. Why? Because if I choose 180, then the leaf node rule becomes violating. If I am just removing 180 from the leaf node and put in the place of 201, then what happens? 157 becomes alone. That also should not be possible according to the B-tree deletion rules. So what I need to do is, I just need to cross on 180. Okay, please do not select 180. Okay, just select 243. So okay, here I am just going to select 243, put that value in the place of 201. Okay, and this is my final answer. Okay, so this is a situation after deleting node 201. Fine. Okay, so what I'm doing, I am just doing where I need to delete internal nodes. I'm just selecting predecessor or successor node from my child nodes. If my child node does not have any proper values, okay, then I moved forward to the another child node. Okay, so what I did, I cannot select 180, so I'm just selecting 243 and go move ahead. Okay, fine. So let's start with the next deletion operation. Next we want to delete 180. See, next we want to delete 180. Students, it is a leaf node. It is a leaf node. Okay, so here the 180 is a leaf node. So what I need to do is same as the first operation. This is case number 1. But here leaf node contains the minimum number of values. It does not contain more than number of minimum key values. It contains only 2 values. So what you need to do is you just need to go second point, on the second point of case number 1. Okay, where there are 3 points are there. If you remember, here it is case number 1, where my leaf node 180, okay, that does not have more than minimum number of values. So what I need to do is either choose the values from the left sibling or right sibling. Okay, I have 2 possibilities. So here it is. Okay, so first I go with my left sibling, that node go with its left sibling, that I want one more node from you. But 114 and 111 says we are already, only 2 people are there, only 2 values are there. See, 2 values are there. So that means you cannot select a value from that node. Okay, so 180 cannot be replaced by any value from 111 and 114. So it goes with the right sibling. So here it is. On the right sibling, it contains 3 values. 3 values. Okay, so that means if from 3 values you can select the values. Okay, so what you need to do is according to the rule you need to select the smallest value from the right sibling. What do you need to select? Smallest value from the right sibling. Then put that smallest value in the place of intervening value. Now this is very important term, intervening value. Intervening value, that means if here I want to delete students 180. Here I want to delete 180. So 180 is a one value. Now I need to select 256. So I want to select 256 from that right sibling. Okay, that is the second value. Okay, now in between of both of this value I have 243 at parent node. 243 at parent node. So 243 becomes our intervening value. Okay, the value in the between of 256 and 180, that becomes our intervening value. So here first students, I need to choose the intervening value. So I have 256 will take the place of 243. 256 will take the place of 243. If you read the statement carefully, what you need to do is you just need to push your smallest value from right subtree to the parent node and take the intervening value from the parent node to the leaf node. So here it is. Select 243 and bring it down in the place of 180. So here it is. I'm just removing 180. 243 will take the place of 180 and then 56 will take the place of 243. Okay, so this is my final answer after deleting value 180. Fine. Okay, so now let's see the next deletion operation. Students, on the next case, if here I want to delete 72. Now here I want to delete 72, but it is situated at the leaf node, so it becomes our case number 1. It becomes our case number 1 where 72 has minimum values. Okay, minimum number of values. So you can't delete 72 directly from the tree. Okay, so what you need to do is either you need to take the values from the left sibling or right sibling. What do you need to do, students? Either you need to take the value from the left sibling or right sibling. Okay, so you have 2 choices. You can select greatest value from the left sibling or the smallest value from the right sibling. Okay, so what the node 79 do? He just go with the left sibling, that I want to borrow one value from you. Now see, the left sibling 36 and 45 both already have only 2 values, so they cannot give the value. Same 90 and 101 both are already only 2 values. So according to the rule, leaf node must contains minimum 2 values. So they also said no to node 79, that I cannot give value to you. That means from the case number 1, if you check the second part, 2C, condition 2C is satisfied, because here 36 does not have any value, even the right sibling does not have more than minimum number of key values. Fine. So both says no, that we cannot give you values. Okay. So what to do? So in such type of cases, you need to move towards the case number 1, second C. Case number 1, second C, where you need to combine with the left sibling or right sibling. See, right now after deleting 72, 79 becomes alone. He just used to try merge with its left sibling and parent node, intervening value of parent node, or right sibling and intervening value of parent node. So here it is. This is case number 2C, students, where if both left sibling and right sibling does not have a minimum number of key values, then the node should combine. The node should combine with either left sibling or right sibling with intervening value from the parent node. Okay. So what I am going to do is, I am just going to show you that how can we combine the values. Okay. So here you will get two different answers. Okay. From all of you, some of may choose left sibling or some of may choose right sibling. Okay. So in such type of cases, what I need to do is, both answers are different. Okay. I will show you both of them. Okay. So here it is. Suppose that node should try to take the value from the left sibling. Okay. 79 will take combined with left sibling and the intervening value of parent node. These four values are combined together, 36, 45, 63 and 79. Okay. Or you can say these four values, or from the right siblings these four values are combined together. Okay. So these are two different scenarios. Either you can select 79, 81, okay, and that right sibling, or 36, 45, 63 and 79 together. Okay, I will show you both of them. Let me start with the selecting values with the right sibling. So here I am going to select the values with the right sibling. Okay, the values are 79, 81, 90 and 101. So these all four values are combined together. So here it is. This is the scenario. Now tell me, 63 becomes alone. Check it out. 63 becomes alone because it is an internal node. Internal node should contain at least two values. So now 63 becomes alone. Okay. So here after combining this, 63 becomes alone. So what we need to do is, we just need to combine 63 again with which sibling? Its siblings 117 and 256, and the intervening node, that is 108. So these all four nodes are combining together. Okay. So why I am doing such operations? Because after moving 81, after taking 81 down, 63 becomes alone. 63 becomes alone. That's why I need to combine 63 with its sibling node. Okay. And intervening value of the parent node. Okay. So here it is. These all four values are going to combine together and see, combine together, and it goes like this. Here it is. So now if you can see, the first level is gone, only my two levels are there. So in insertion, students, your tree height is increasing. In deletion, B tree height is decreasing. Okay. So but make sure all leaf nodes must be at the same level. So if you follow the perfect rules, the leaf nodes must be at same level. So now, as such type of deletion operations, 63, 100, 117 and 256 are combined together, making a root node. And what about the such nodes, the leaf nodes? Okay, you need to set these nodes according to the rule. Okay, smallest values on the left side, greatest value from the right side. Here it is. These all four nodes combined together, and this becomes my final answer, where 36 and 45 becomes on the left side of the 63, 100 and the values which are greater than 63 and less than 100 must in between of them. Okay, the values which are greater than 100 and 117 like 114 and 111 are in between of them. The values greater than 117 and less than 256 like 157 and 253, okay, must be over there, and the values greater than 256 are on the right side on the last node. So students, this is my final answer number 1 if I choose the right sibling. If I choose the right sibling after deletion of 72, this is my final answer number 1. Okay, now some of you may choose left sibling. Then what to do? Let's see. See, I'm just again starting with the left sibling. Some of you may choose the values from the left sibling. Then what I need to do is I just need to combine all 4 values together. That means 36, 45, 63 and 79 are combined together, and there goes like this. Okay, now 81 becomes alone. So 81 is going to become a pair with its sibling and the intervening value of the root node. Here it is. Okay, so 81, 108, 117 and 256 are going to combine together and they make a formula, and this becomes my final answer. Okay, where root node has 81, 108, 112 and 256. Fine. So this becomes my final answer number 2. So students, after taking the values from the left sibling, this is my answer number 2. Okay. So see the difference between both of the figures. This is my answer number 1. Here it is. This is answer number 1. Okay, where I am going to select the values from the right sibling. And this is my answer number 2, where I am going to select the values from the left siblings. Okay, so you can check both the answers. Both answers are correct. Both are following the properties of B tree correctly. Okay, so you can do deletion operations such like this in B tree. Fine. So that's it for today's lecture, students. Thank you so much.